Hey differential equation students. What I'm going to be doing in this video is taking a matrix like this. We're going to be looking at this system of differential equations, and we want to show that these vectors form a fundamental set of solutions. To start off with, what I want to do is actually make sure that they're solutions. I've already said what A is, so that's good. I'd like to actually load in a couple of packages. So I'm going to load in with linear algebra and with the MTM package that will make things easier to evaluate. And let's start talking about these solutions. So let's see, Sol1, I want to enter that. So I need to enter a 3-row, 1-column vector. That's going to be 5, tab 2, tab 3. And then what I want to do is I want to multiply that times e to the 2t. Okay, to multiply, you can use a period Sol1. So that is the a times x portion. But we can also differentiate Sol1 with respect to t. And here's the important thing. You get exactly the same answer. The derivative equals a times the vector. Let's do that again. Let's call this Sol2 and adjust this so this is 1, tab 0, tab 0. And let's adjust that exponential so it's e to the t. Let's find a times Sol2 and let's differentiate Sol2. Yay! Again, things are equal. We've got solutions. That's good. Let's do that one more time. So there's Sol3. Let's take a times Sol3. Wonderful. And let's differentiate it with respect to t. Yay! We get the same thing every single time. So what we have here are 3 solutions. What we don't know yet is whether or not they form a fundamental set. And for that, we need the Wronskian. So what I'm going to do is I'm going to get rid of all this stuff. And let's do a determinant. Now, a nice thing about doing a determinant in this case, so we don't have to take derivatives. We just have to enter the matrix. It's going to have these entries. So we're going to have 5, and I need to remember that that e to the 2t is part of all of the first column. So that's going to be e to the 2t. The first entry here is going to be 1 times e to the t. So that will just be e to the t. Next entry is negative 1 times e to the negative t. And we've got 2, we're back to that first column again, so I have to have 2t. And then I have a 0, and then I have a 2e to the negative t. Finally, finishing out the first column, we've got 3e to the 2t. We've got 0, and we've got 0. Great. Take the determinant of that. Let's do a little bit of simplification. Yay! Note what we have here. We have a quantity that is non-zero. Since it is non-zero, that means that these 3 solutions form a fundamental set. In other words, any solution to this equation is some linear combination of those 3 solutions.